Good afternoon, everyone. My name is Matt Dibert, and I am the Program Manager for the Electrical Association of Philadelphia. This afternoon, I am joined by my colleague, Sarah Hagee. I'd first like to thank Staco Energy for sponsoring today's session. Today, presenting from Staco Energy, we have Regional Sales Director, Marianne O'Connor, an electrical engineer who has worked in the power industry for over 25 years. We have Director of Three-Phase Product Management, Jeffrey Smith, who has extensive industry knowledge and expertise in UPS systems for over 30 years. And we have Application Engineer, Phil McWriter, who has an engineering degree and expertise in power distribution and controls. Also joining us is Scott Stilley, owner of eSite Systems, who has been providing PQ and voltage regulation power solutions on a wide variety of applications in the PA, Delaware, and South Jersey area for over 25 years. Before we get started, please note that because we are recording today's session, your cameras and microphones have been turned off. However, you are encouraged to ask questions using the chat feature. We will facilitate Q&A after the presentation. It's now my pleasure to introduce our speakers, Marianne, Jeffrey, Phil, and Scott.
Thank you.
Thank you,
Matt. Thank you, EAP, for this opportunity to provide you with this presentation. Just a little introduction to eSite Systems. We're a traditional manufacturer's rep here in Pennsylvania. As Matt said, we cover Pennsylvania, Southern New Jersey, and all of Delaware. I have a variety of mission-critical products, but today I'm excited to spotlight Staco Energy. I really like Staco Energy. I've been with them for many, many years, and they just never say no to a product that one of my customers comes down the pike and says, "Can you do this?" So they're very nimble, and I really enjoy working with them. Could you go to the next slide, please? So again, Matt did all the introductions there. I was expecting to do that, but that's okay that Matt did it. He did a much better job than I did. Next slide. So who is Staco Energy? I get that a lot. They'll say, Staco, who? But Staco is an 85-year-old manufacturing company. They manufacture UPS supplies, harmonic mitigation, emergency lighting, frequency converters, power factor correction, power conditioning regulation, variable transformer test sets, and power quality and load studies. And we're not going to talk about all of those today. Next slide. We're going to be talking about power factor correction, UL 924, lighting inverters. Marianne O'Connor is going to do that. Power factor correction is going to be by Phil McWriter. Sorry about that. And containerized solution is going to be by Jeffrey. And Jeffrey's going to go into a little bit of a new product that Staco has specifically for elevator applications. Next slide. So here is a select customer list. We have Amazon, Microsoft, Johnson & Johnson, Sephora, Schneider Electric. I'm not sure if there's anybody from the Schneider Electric group attached, Merck, Tesla, GM, and Ohio State. And with that, I'm going to turn it over to Phil McWriter, where he will be talking about the power factor correction. Next slide.
Hello, everyone. So I'm going to start off with power factor correction, I'm going to go over it, say, hey, what is power factor? What could cause power factor problems? How do you know that there's issues? And maybe some solutions to correct the issues, and solutions that some of the products that we have to offer, and wrap it up with where to look for power factor applications to play. Next slide, please. All right, so let's get the boring engineering vocabulary out of the way. So if everybody's good with trig functions, we can look at the the power triangle here, and we can go through some cool math, but that's really not fun. At the end of the day, power factor is your real power measured in kW over your apparent power kVA. So that's it could go into more detail, but it's really boring, and I'd rather talk about beer. So let's talk about beer. We all like to buy beer, and we buy it in the glass, and it kind of translates to your apparent power, which is what you buy from utility. And if you have a good power factor, you get a nice full glass of beer. If you have poor power factor, you're going to get a lot of foam, and you're not going to get a good value per glass. So that's kind of in a nutshell what power factor is. And let's dive into it and see what could cause some poor power factor. Next slide, please. All right, so what causes poor power factor? Well, usually poor power factor is when you could have large inductive loads or large capacitive loads. Most industrial facilities have large motors and large pumps. So that's probably where the focus of poor power factor is going to originate from. So large inductive loads definitely could cause poor power factor. You say you install a new piece of electrical equipment and you install it on your A phase, and you keep installing new equipment on your A phase, you're going to get a unbalanced phase. That's going to cause poor power factor. Maybe you got some aging electrical equipment that's causing some issues that could cause poor power factor as well. That could also introduce harmonic currents, which could affect your imbalance and would cause more of your apparent power needed to drive your equipment. Incorrect wiring is also really big. If you have too small of a cable on your input to your motors, that could cause poor power factor, because you need more apparent power to drive through the small wire. You're going to have large voltage sags. So still, a lot of those could cause, there's more reasons why you could have poor power factor, but that's kind of, those are the main ones. All right, let's look at the next slide. How do you know that there's poor power factor issues? Well, sometimes you really don't know until it's too late. Say you get in your monthly utility bill and boom, it spikes up. Well, why did it spike up? That could be because of poor power factor issues. Some utility companies will charge you for poor power factor. Maybe you have a facility that's the same size as your neighbors, and you're talking to one of the facility engineers there, and you guys are talking about like your utility bills, and you realize that their utility bill is much lower than yours. And if it's the same size and the same load and same demand, well, what's going on there? Why would your utility bill be higher than your neighbors? Well, maybe you got poor power factor. Again, faulty or aging electrical equipment is a big cause for power factor issues. So maybe you have great power factor and you just want to get peace of mind. Well, that's when you want to do a power study. And a power study will truly identify if you have an issue. All right, let's get into the next one. So now you say, hey, all right, I might have poor power factor. Well, what can I do about it? Okay. So like large industrial loads, like motors, pumps, they create a situation where your inductive load is lagging behind your voltage. Your voltage is leading current. So to correct this, you need to add some capacitance to close that gap. So here's a little waveform I grabbed off of Google Images that really does a very good job of explaining like the waste with the foam and the beer about how power factor is interacting. So you got this red in the middle, and that's like the foam. That's what's being wasteful. And some utility companies will charge you for that waste. And you can correct that by adding some capacitance into your network, into your equipment circuits. And adding that capacitance will close that gap, and it will reduce your overall waste, and it will increase your useful power, your real power, so that you can have better power flow into your equipment. All right, let's look at the next slide. All right, so okay, so we install a capacitor. Well, what does that capacitor look like? Well, this is our this is a Staco VIR, and 90% of the time, 99% of the time, we're going to recommend a pH unit because it has detuned capacitors. This helps protect the capacitors from blowing up. We got lots of different options, lots of different sizes. We have switched capacitors that will turn on and off based upon your load and your demand. It's a microprocessor based, so it's fully automated. We got lots of different types of enclosures. NEMA 1, being indoors, 3R being outdoors. We can put these in outdoors with hot environments, and we can hook up HVAC to these to keep them cool in really hot places. And we can also have some dust tight enclosures. So we have a lot of different types of options for whatever the application demands. Let's go to the next slide. So this is a real world example of project that I just worked on. We had a customer come to us and their monthly electric bill was $90,000. And they're like, oh, that's a lot. We need to have some cost saving measures in place. And so we start looking at it, and there's lots of concerns over this very high monthly charge. So they're like, well, what's going on with our monthly bill? Well, let's figure out what's going on in our facility. So let's do a power study to measure all of the loads on all the motors and see what's going on. And so after the power study is completed, we conclude that the power factor is around 90%. And anything below 95 is going to probably fall into that poor power factor range. So recommend installing a power factor correction capacitor to add some reactive load, a capacitive load, to decrease the apparent power. This will minimize that gap in the waveforms from the previous slide. It minimizes the foam in your beer. So after installing it and doing the commission and getting it up, remeasured everything and increased that power factor back to 97%. So now the business can operate, and it decreased their monthly bill to about $80,000. So it's still very expensive, but it's a very big facility that's running a lot of equipment. So in just a few months, you completely paid off for the cost of equipment, making a power factor correction capacitor a great return on investment. For this particular application, based upon the demand and the power factor readings, we went with a 400 kVA capacitor to bring them from a 90% PF to a 97 PF. All right, so let's look at the next slide and say, all right, well, where's some other places to take this and recommend, some other businesses, some other industries out there. Automotive, lots of motors, lots of processes. Electroplating, again, lots of high inductive loads. Hospitals, lots of equipment. I was a radiation engineer previous life, so when these radiation machines would kick on, huge power spikes. So it's great application for power factors. Brewery, it makes sense. We're talking about beer, so lots of pumps, lots of processes. Oil field, lots of pumps. Some types of loads that have poor power factor: induction motors, furnaces, welding. All of those have high power demands and have large inductive loads. And any type of inductive load causes that current lagging behind the voltage. So lots of places, lots of factories that have poor power factor, and they may not even know it. So it's a great chance to ask these facilities, hey, what's your monthly bill like? Do you think that you're paying too much for your power? That opens up the conversation to drive a power study, and you can fine tune exactly what's going on with your power system. The cool thing about power factor capacitors is that you can put them on your service entrance switchboard, and that will kind of correct any problems downstream from your main service entrance. So pretty cool product, pretty cool application. And we're doing a special EAP discount. And so you can do a power study. And, you know, if we're looking at a power study, I'm going to recommend some equipment to go along with that. And, you know, we'll kick you back 50% credit when you order 50% credit of the power study when you purchase the equipment. So you can get half off of your power study when you get a capacitor to solve a problem. And so you get a great return on investment, and you can save some bucks using this EAP discount. If you got any other questions, just reach out to Scott, and he'll send you my contact information. I have another really cool application using an Imperial Stout beer, and so I'm excited to talk about that if anybody's interested. The beer in the first slide was a lager. I'm a big beer fan, so I got another really cool application that utilizes Imperial Stout that was aged in bourbon barrels. Super excited to talk about that. So if you want to hear anything more about that, just reach out to Scott and he'll give you my contact information, and hope to hear some questions and talk to you.
Thank you, Phil. And I was to mention that special EAP discount in the beginning, and I forgot. So thank you for bringing that up. And yes, so your power factor correction, you're going to need a study to see how bad it is and what can be done. And so if you do one, and then it's recommended for equipment that you're going to need to purchase, you'll get 50% of that power study, the cost of that power study back. Now we're going to go on to Mary Ann. Next slide, please. Okay.
All right. Thank you, Scott.
You're welcome.
Thank you, everybody, for attending. Wanted to talk a little bit about what's happening in the emergency lighting arena these days. We are definitely seeing lesser demands for lower loads. So with the LEDs, the power requirements are declining. So the KVA rating or KW rating of the lighting inverters is definitely going down. I know about 3-4 years ago, I was seeing a lot of, let's say, 15 kW single phase lighting inverters. Now I'm hard pressed to see something that high. They're falling in the under 10 kW range, and I'm seeing a lot in that 5 kW and less. When you have a centralized lighting inverter, which is what Staco has, it's less to maintain when you have that centralized lighting inverter. Unlike some of the lighting fixtures out there that have a battery for each one, and you're putting it in, you have to maintain. What happens if, gee, you forget to put in the battery, or you don't maintain it, and lights go out, utility goes out, and then your lights don't come on when they should. Another growing trend that we're seeing is microinverters because of the lower power demands due to LED, and we're seeing the microinverter be very popular to back up, let's say, a zone of lights. So if you go into an office or a restaurant and you see a whole bank of lights there, that microinverter can back up that zone of lights. This way, they're not each individual light does not have a battery. So that's a good way too of also controlling a group of lights. So with the microinverter, there's decreased maintenance costs. So you're only really dealing with, let's say, one microinverter that might be handling 20 or 30 lights. You're having less maintenance, less liability. And also too with the design aesthetic, especially in a restaurant, makes it easier because it fits up into the ceiling. So the aesthetics can be, they're not impacted. On the three-phase side, we're definitely seeing, again, lower power requirements. So on the typically 10 kW, we were seeing a lot of 9 kWs. Now we're seeing more in the 3.5, the 5, and the 7.5, and that is on Staco's roadmap. So to handle those kinds of smaller loads. So that should be coming out this year. Another thing that's happening is the increase of power over Ethernet. I think it's a little slow, kind of taking off because it is a little bit of a bear for installation. But once the install is done, the benefits and the flexibility is excellent. But it's also a little bit more expensive. And basically, with power over Ethernet, they're putting everything on the network and from source to illumination. So our centralized lighting inverter would be backing up the switch that handles all the emergency lights. But we're seeing that kind of popular in certain territories. I'm seeing it more in New York, New Jersey, Texas. But I think over the next few years, we'll definitely see an increase on that. Next slide. So you'll hear terms centralized and distributed. There's pluses and minuses to both. The distributed is where, let's say, the individual light has a battery, so it's individual to the light fixture. On the centralized side, our lighting inverter would be backing up a panel or a switch. And then sometimes you have like a hybrid where you might have a zone to that speaking to that microinverter, you'll have that handling different zones. So it's not just one microinverter, but it could be a few handling different zones of lights. And on centralized installs, you're using existing power infrastructure. They're pretty easy to install. They're easy to maintain. You do have a little bit more cabling. There are some distance limitations. On the distributed, you definitely use less cabling. Distance is not really an issue, but at the same point in time, it's a lot more to maintain. So it's something that you kind of have to look at the pluses and minuses, but we certainly see where the centralized inverter definitely handles the ease of maintenance for the emergency lights. Okay, so next slide. You'll hear terms online and offline for the lighting inverters. In an online unit, the inverter is always on. So your power is coming into the inverter. It's being cleaned up because then you're getting a very nice sine wave out to your load. So the power is being conditioned. The inverter is always on. If utility goes out, it's automatic. You don't really see any lag. It goes right to supporting and putting the lights on. In an offline unit, the inverter is not on. The battery is being charged, but the inverter isn't on. So you're not getting that conditioned power that the double online conversion unit is giving you. And then with the offline unit, as soon as the utility does go out, then the inverter turns on. But all of Staco's online inverters are double online conversion. So all of our lighting inverters will condition the power and be on and provide the backup when the lights go out. The utility goes out, and it will keep the lights on. So, all right, next slide. For the emergency lighting, UL 924 is the code that we go by. So basically, what the UL 924 code says is you're testing the UPS and the battery, and together they will provide 90 minutes of backup. So that's the UL 924. In some cases, they want more or less lighting. We've gotten inquiries where they say, okay, hey, we want to have 2.5 or 3 hours instead of 90 minutes. So we can do that. We have oust units, which basically is akin to the auxiliary lighting, where your lighting requirements for the runtime can be more or less than the 90 minutes. So we have the flexibility to do the UL 924 or to lower or extend that runtime with our oust units. Next slide. So with emergency lighting, you have maintained lights, and basically those are the lights that are on all the time in an office or your facility. When the power goes out, they will go into emergency light mode, which usually means a lower light level. Then you have non-maintained lights. Those lights are not on, but they're being charged. And as soon as the power goes out, those lights will come back on. So, and then how that operates would be up to what the facility wants to do and what the engineers are doing for that. Next slide, please. I just like to put up the emergency lighting codes. Primarily, we deal with the UL 924, which again states that for 90 minutes, the lights will stay on. That NFPA 70 is also for something that we also deal with. It's for the system, and the average time is 30 minutes. Then there's one for healthcare facilities. So it's kind of just good to know the codes that are out there and kind of which markets they service and address. So next slide. A trend that we're seeing is the power over Ethernet. Pretty much everything is on the network. So it's your sensors, your lighting. It pretty much controls everything from source to illumination. And basically you're getting data points, and that those data points can help make the building smart. And it kind of makes the building a digital building, if you will. So people are looking for information. Are the sensors picking up that there's people in a room? Do they need to raise the temperature? Do they need to lower the lights? So it's all a way of becoming more energy efficient. And where the centralized inverter is great in this, because you have a switch that's handling that source to illumination. So you just have one centralized inverter backing up that switch for the emergency lights. Again, we see that this is something that's kind of slow taking on, but I think in the future it will suit certain companies, certain installations, but I think we'll definitely see an increase in this. But the centralized inverter is perfect for this kind of application. Next slide. So with Staco, our products can cover single phase and 3-phase. We have a very good array of offerings in that area. On the single phase side, we have small and large frames, and they have different kW ratings. So from the small goes from about 750 watts up to 3 kW, and then the large frame goes from 4 to 10 kW. And we really don't see a lot of applications where the rating is over 10 kW. And we have different features, SNMP, we can put in various features that might be needed, maintenance bypass. We can also put these into NEMA 3R 4X cabinets. We have some customers who say, hey, I need the lighting inverter, but I need it to be outside my building. Can you put it in NEMA 3R? And we will, and depending on where it is, we'll have climate control in there so it continues to operate in its optimum environment. So next slide. Then we also have 3-phase lighting inverters. On the PLT, it goes from 9 kW up to 54 kW. And this year, towards the end of the year, we'll be coming out with the 3.5, the 5, and the 7.5. These are a very nice footprint, and it provides the 90 minutes. And again, we can also do the oust unit and add runtime if needed. So we do a lot in this range, in the 9 kW to 54 kW range. And we can also do different voltages. It's a native 208, 120, but we can add transformers. Again, we can also add a NEMA 3R or 4X cabinet to accommodate your requirements. Next slide. And this is our PUL 924 3-phase unit. It goes from about 58 kW up to 225 kW. Again, we can add an SNMP card, maintenance bypass. This is a 480 volt 3 or 4-wire in and out. And again, we can also accommodate it with maintenance bypass, SNMP, do NEMA 3R, 4X, and again, vary the runtime if we need to, based on the requirements. Next slide. We are into pretty much all kinds of applications that you would need backup lighting for. So a lot of residential buildings, healthcare, sports venues, We've done the large co-locations, data centers for egress lighting. We also did the tunnel in Seattle for the emergency lighting, and also all the Sephora retail stores. We have a smaller light frame that kind of fits into the ceiling, and all the stores have that to back up the lights in the retail stores. Okay, and this is an example for Cloud HQ data center. You have a lot of these facilities that are 1 million square feet or more, and sometimes they'll have just one lighting inverter backing everything up. Sometimes they'll do 2 per floor, but this takes kind of the higher wattage 3-phase lighting inverters. So we see a lot in the co-locations falling in that 60 to 100 kW requirements. So we do a lot with Cloud HQ and some other co-locations. So that's just a typical example of where the 3-phase lighting inverter definitely does the trick. It's easy to maintain. They have 1 or 2 per building, and definitely keeps the lights on when the utility fails. Okay, I think next slide. So yeah, thank you. If anybody has any questions on lighting inverters or applications, we can definitely help you out.
Yeah, there was, Mary Ann, a couple questions that came through that I just addressed a little bit, and I'll read them at the end, and we can discuss that further. The next one, Jeffrey, I mentioned he's going to talk about containers, but I also mentioned he's going to talk a little bit about an elevators, power on with elevators, and an application that we've been working on here. So I'll turn it over to you, Jeffrey.
Is everybody still awake?
I hope so.
All right. One of the biggest problems we have out there right now are people being stuck in elevators. This has happened for years, and it's finally got to the point where the industry and legislative bodies said enough's enough. So what they have been doing in the past is adding some sort of a battery system to where it can get the elevator to open the doors at the next location, either go up 1 level, down 1 level, open up, or go all the way down to the bottom, open up and stop. And what has happened is, just in the last few years, California, I know they're strange out there, but California, they have added that they need to run for 2 hours. The reasoning why is they have so many residential apartment buildings where there's a lot of older people living in these facilities where they can't use the stairs. And any facility that has more than 4 floors, and when I say more than 4 floors, it could be underground and above. So if you're on a 5-story building and you also have 2 floors underground for parking, then you're going to have an emergency elevator to be able to get people out of the facility. The fire department, the fire marshal said, we want to be able to, as long as there's no fire in the elevator area, in the shaft or anything like that, they want to be able to use the elevator up and down to be able to get people out for 2 hours. Well, what happens with that is, most of the time, every elevator is worked on by a motor going up and down. We won't even talk about the power factor correction that we would possibly could use for this, but what happens is you got a regenerative power that's being sent back from the motor. When you have a motor that when you're going up, you're using extra power when you're going up, making the elevator go up, because you have an acceleration. Now, when you're coming down, you're coming down like this, but the actual motor may be spinning the other way to slow down. And what that is actually doing is that is actually putting power. It's making that motor act like a generator. Okay, so you're putting power back onto the utility. UPS systems, emergency lighting systems, they have transistors. And what that does is, if you try to backfeed the inverter system, it raises the DC bus. And if you raise it too fast, that's when they say the smoke comes out of the transistors. We don't like that. So what we've done is we've added a load bank onto the system at this time. And what that does is it allows the regenerative power to be fed back through the load bank and burn off instead of being fed back to the UPS. We have, I want to say about 60 of these units that are feeding elevator systems that basically go from where it's at right now to the next floor or to the bottom and stop. This last January 2023 is when California put in place that they want it to run for 2 hours. So this is when we have to increase the battery runtime and the capabilities to make sure that with the regenerative load that's being fed back, that the elevator can go up and down for 2 hours and still bleed off that regenerative power, so we don't take a chance of damaging any type of part of the UPS. So this is what we're looking at. And you can see it's the powering the elevator controls, the cab lights, elevator, and the pit lights. The pit is where everybody, the service guy might be doing the work. So we'll have power for the lights for that, power for the cabin lights, and then we'll have power for our controls to make sure that when there's an outage, as you can see on the top here, and I'm pointing to my screen, the ATS is there. So when you lose utility power, it transfers over. So there's a gap in power right there just for that momentary portion of it. And what happens then is it transfers over to the UPS. Now on the top there, you see where the little circle is where the UPS has a line going out there. That's control power to the elevator through the cabin lights. So that keeps the lights going. So what happens? You have a power outage and the light goes out in the elevator, everybody's freaking out. So what we do is we power the lights for the elevator. So it may stop, and then all of a sudden it starts going again because it transfers over. And that's one of the things that we've been able to do to make sure that the customers, the people that are using the elevators are not, don't get any type of an anxiety attack because of they're in a dark elevator. It stops for a second, the transfer makes complete on the ATS, then the power keeps going on. Just think about this. The elevator controls are basically a computer. So if they lose power, what has to happen? Reboot. Everybody's had to reboot their computer. So it reboots. So it takes a period of time to do that. That's why we feed power over the controls, so it doesn't have to reboot. It just has to go through and say, okay, I was in between floor 2 and 3, and I want to make sure that I keep going in that same fashion. So it picks up where it was off and goes to the next level. What it does then is, like I said, it allows the system to be able to be operated for up to 2 hours. Now, if you want longer runtime, they can do that. Why are we doing this instead of adding a generator? Well, because of EPA requirements in California, it makes it too cost prohibitive for putting in a generator. Because if you use your generator too much in California, they fine you. So that's one of the things that we're looking at. What's a different way? Batteries. Everybody's going to batteries now. Cars are going to batteries, planes are going to batteries. They're trying to do everything that way. So we have the batteries for their elevator systems. All right, next slide. So it shows you there's, we got backup lights for the cabin lights, and the elevator. In order, do you want to be able to make sure, like if you're in a commercial office building, and this is what, say a doctor has a surgical suite, this way that if all else fails, they can bring the clients down and get them out and get it to a hospital if that's what's required. Same type of thing, 3 levels or greater, that they have to be able to have the backup for the 2 hours. Like anything, 90 minutes is what they were looking at originally for UL 924, but because this is something that's different, nobody really knew what to do. So what they did is they said, we want to use UL 924 units here, but we want in California 2 hours. In New York, New Jersey, they've been saying 15, 20 minutes. We have a generator, and or we just basically want to make sure we get people down to the first floor, open up the doors and stop. So these are the different things that you can do. Next slide, please. Motor loads, like I said, it can harm the emergency lighting inverter. There's got to be a VFD with braking resistors in order to not require the load banking. That's what's out there right now. So with the regenerative loads, we have to put the Staco ERS system, and that puts the load bank in the system to block out the regenerative power. What we need to know the load profile of the elevator system. What's your voltage? All the details on the elevator, the KW, the KW for the regenerative load power. We need that information. Capacity of the lift motors, the type of elevators, different manufacturers, whether it's Otis, Cone, Schindler, Thyssenkrupp. These different manufacturers do things just a little bit differently, and we want to know which manufacturer we're using and the model number of the elevator. So we have different profiles set up for each different unit. So we can use the emergency lightings on these types of applications because that's what everybody, the jurisdiction locally, that's what they're asking for us to use. Next slide. So potential regenerative power, that's what we have to look at for concerns. We have to get rid of that. We have to remember, we have to look at elevator, the lighting, any type of fans, load bank, and a design margin so you can make sure you have that to be able to run as long as what's required locally. What type of motor? Is there a VFD? Because in New York and New Jersey area, it's a lot of the older type systems. They have just a standard motor. There are no VFDs, variable frequency drive, or any type of thing like that to feed it. So there's different ways we can work with those types of systems out there. And then in California, the limits of volume of electrolyte. So if there's more than 50 gallons of electrolyte, they call it now 70 watts of power, kilowatt hours of power for the battery, that they want to have spill containment, pillows, all that type of stuff. Even though they're an absorbed glass mat battery, you could drill a hole in it, turn it over on the side, charge the heck out of it, and still maybe get a couple of drips out of it. But that's the way it goes. We do what they ask for. Next slide. So the emergency lighting is placed on here. As you can see, this is a standard, the way it looks. You see the green lights. Right now, this is utility feeding the system. We're good to go. Next slide. We're on emergency power right now. So what it is the UPS, emergency lighting inverter, is now feeding the load, and it goes down there and feeds the system. So the red arrow is showing this is where the regenerative power is coming back, flowing back into the resistive load bank. And like I said, we have over 60 units out there right now that utilize this. We are just starting to put out systems now that are running for 2 hours, because that just came, this January of this year requirement for California. Next slide. We have the first line PLT, 10 through 60 kVA. We are utilizing these units. Depending on the system, it's typically going to be a 30 kVA or above. Next slide. And we have put in systems where we have utilized our larger units. We put in 100 and 125 kVA systems because their systems were 480 volts in and out. And so that made it a little bit more easier to be able to utilize this series, because that's its base model. Next slide. Okay, now each of these types of systems, everything that Phil was talking about, everything that Marianne talked about, and the stuff that even Scott has mentioned, all of this stuff is can be put in NEMA 3R or NEMA 4X enclosures. And these are the types of things that we're able to do for all of the systems out there. And one of the unique things, I've worked for many UPS manufacturers out there. When I came to Staco, one of the big things is like, okay, what is that out there? And they go, oh, that's a NEMA 4X enclosure. I've said, yeah, it looks stainless steel and it's got air conditioners on the side. And I go, what are you doing there? That's one of the things that they looked at and they go, you know what? That's our, in a sense, claim to fame, you know what you want to say? Because if a customer says, this is what we need the UPS, but we need it outside, or we need a harmonic filter, but it's got to be outside, and you know, it's in the desert. So Arizona, we put these out there. It's 145 degrees outside in the summertime, and in the wintertime, it'll get down in the 30s. Imagine the desert. Yes, it does get cold out there. So these are the types of things that we put on air conditioners and have heaters on, and that's in our containerized solutions. We've done, we're working on one right now that's going to Canada. It's a harmonic filter, same type of thing, 400 amp system, and it's being put in because it's in a outdoor facility. It's going to be in one of these enclosures, a NEMA 3R with air conditioning on each side. So you can see the different things. We put these in for mobile applications. Go to the next slide. Show you some pictures. What we do is, you can see up here on the top left, just one of the drawings that we have, and that little box on the side is the air conditioner. These are the types of things that we can add on air conditioning on the side to make sure the equipment stays in a proper environment, so we keep these going. Especially if you look at the right-hand side, those are batteries. We get many applications where the customer says, we don't have any room in our facility to be able to put this, but if you take batteries and stick them outside, we know they're not going to last. They need to be in an environment where it's 77 degrees Fahrenheit all the time. Some people say, oh, that's an average. Well, if the average is, it was 30 degrees the other day and it's 92, but the average is 77, that doesn't work. We have to keep it at a constant plus or minus a few degrees to be able to make sure that those batteries will be there when you need them. Down below is a container, shows you exactly that some of the bigger systems that we put together in. So these are what we're doing. Next slide. Outdoor, this is some of our systems for our industrial variable regulators. I don't do this product, so it's one of those types of things. I don't know that much about it, but it's one of these systems that we have put it outside. You can see it's sitting right next to the switch, the substation there. And this is one of the things we put in there to be able to make sure the customer is all happy and there. Next slide. There's your stainless steel application. You can see that one there. And then down below on the side, you can see that one. It looks a little weird. The unit there with the black stand there, that's the UPS, and has batteries inside. What this is this is on the borders. We put these down in Texas on the borders and along the southern border, and actually on the northern border too for Canada. And these are to run the X-ray machine for a semi to drive through, so they can make sure that they don't have people in there or other contraband that would be coming in the States. So these are the types of things. And just remember, you go to the southern border, it is hot. I mean, it is really hot down there. So with these types of systems, we're able to maintain and keep the systems going forever. Next slide. Thank you. Scott,
Thank you. Yep. Thank you, Jeff. So we do have some questions, and I really appreciate people for asking the questions, and I'll go ahead and read them. Let me bear with me here for a second. William asked, do most of the Eastern utilities have power factor costs? And I'll say, I believe they do. And Phil, can you add to that?
Yeah, yeah. I know in the Midwest they do. In a couple of states we've worked with. Yeah, they charge. And it kind of comes down to the individual local power utility. And some utilities will have right on your bill, you're getting charged this amount for your poor power factor. So if you're unsure, you can look at your utility bill and read through it. You can send it over to Scott or myself, and we can take a look at it and see if you're getting charged for it. But both those work. So it just kind of comes down to what your local utility company, what they do at a local scale.
Yeah, I have seen it where this by what a county by county where they, this one county, the utility will charge them a fee for their power factor. So I hope that answers your question, William, and you can type another one if you'd like, if it didn't, and you can also reach out to us at any time. Another one comes from Steve. He asked, during your presentation, Marianne, you had a slide up with the UPSs shown, and his question is, do the cabinets shown include the batteries? And my answer to that was, some do, yes, not all, however. So if it's a small enough KVA and we have internal battery options, I believe we have some that can go the 90 minutes. But once you get pretty large KVA size, the 90 minutes, you're going to need an external battery cabinet. Am I right there, Marianne? You're on mute, Marianne.
Sorry about that. Yes, typically we do have the external, especially for the 3-phase units. On the single phase units, you'll see it's built in together. But we do have external battery cabinets most of the time to handle to your point though, on the lower KVA, they can fit into the UPS cabinet well, but most times it's an external cabinet.
Right. So another question from Steve is there an option to have input transformer if a neutral is not available at the buyer's source? And I said, absolutely, yes. It was a great question.
Yes, absolutely.
Yeah, very flexible, depending on the configuration, you have to take a look at, that's the type of information that we need in order to meet the customer's requirements. We need to know if it's 4-wire. We need to know if it's 4-wire in and out. If it's only 3-wire in and 3-wire out, then that's a different type of configuration that we can handle. One more question here. Have you partnered, this goes to you, Jeffrey, have you partnered with any elevator manufacturer to provide them with Staco regen system?
Right now, we're working with one that they've asked us to quote them directly so they can work on that. So we're working on some OEM type systems right now. It's one of those things, it's so new with California and having this longer run time, it's difficult to, because there's so many different elevators out there. There's like 6 different elevator manufacturers in California that we're trying to deal with. And some of them are very open and easy to work with. Others, this is all we have, and boom, that's all you're going to get.
Right.
I'm also seeing it on more engineering specs where they're putting it on the with the specifiers, and they're working on it. I see that in the Mid-Atlantic region. We're working on several with the engineers.
Yeah,
so.
it could be a separate item. But I think as we get more and more used to it, the elevator companies will start to partner with some folks, like imaging companies needed, good power quality. So they wrote it into the specification. Well, now imaging companies, a lot of times will supply their imaging equipment to the hospitals, but it'll include the UPS system.
Correct. We do that all the time with some of our OEMs also.
Yeah. This one's from Jim Clark. He says the power factor charge from the utility can be hidden. PECO adjusts the measured demand to a higher billed demand based on the power factor. Thank you for that interesting comment there, Jim. So they can make it a little tricky for you to figure out. And I don't know if you've seen that, Phil, where we have to really do a deep dive or do a power quality study before we can really determine the full effect and savings for the customer.
Yeah, I think at the end of the day, it's like if you have a concern or if you have a question, do a power study, because that will give you all the information that you need to make an informed decision. Sometimes the company will do that, say, hey, this is your rate now during peak demand, this is your rate. And it's difficult to figure it out. And doing the power study will definitely tell you exactly what's going on.
It'll
Great.
also tell you that if you have issues with harmonics too. So that gives you both the power quality for the power factor and harmonics that could happen within your facility.
Right.
Well, thank you. There's no more questions there, so I think we're right on time. I just want to remind everyone of the EAP special for this, and that is a power quality. If you do a power quality study, 50% of that cost will be taken off any equipment that's needed to mitigate that. So we really appreciate EAP for providing us this platform. EAP is great. We love your show that you do every 2 years, and we like to provide solutions to our customers. And out of all my manufacturers, the easiest is Staco Energy products, because I'll do my little commercial, because they're so nimble. Like I said, they really do step up, and some of those containers that Jeffrey was showing were some of the jobs that my customers came to me and said, can you do this? And I picked up the phone and called Staco, and they said yes. And and we all learned from it, and we all have a better product for it. But again, it's solving the customer's problem or solutions. We like to be solutions providers for our customers. So with that, again, thank you for all that have attended. We really, really appreciate your time. And I guess that's it for now. I hope you all have our contact information. If there's anything we can do for you, please just reach out to us. And again, I'm local. I'm right here in Philadelphia, right outside of Philadelphia, in Blue Bell, Pennsylvania. And I covered the whole state of Pennsylvania, southern New Jersey, and Delaware. Thank you.
Well, thank you, Scott. Thanks again to Marianne, Jeffrey, Phil, and Scott for presenting today. I'd like to thank everyone for joining us today. The recording of today's virtual trade talk, the slide presentation, and our speakers' contact information will be shared via email tomorrow. So with that, have a great rest of your afternoon, and we'll see you at our next virtual trade talk. Take care now.